exponent. So 10.1 is talking all about exponentials. We're going to dive more into exponentials. So something we're going to talk about is talking about the nth root, which I'll explain here in a second. We're also going to talk about the difference between exponents and radicals and how those go together. We're going to convert between radicals and rationals. I'll show that here in 1 second, and then use rules and all that fun stuff. So in the last video, what I talked about was we found out that the square root of 9 was equal to 3, and we found out the cube root of 64 is equal to 4. Okay. So technically, in a square root, when you don't have a index, as we called it in the last video, you think of it, this as an index of 2, and when you think of the 9, it has an exponent of 1. Both of those are unseen. Sorry, it's just what it is. Here, similarly, this 64 has an exponent of 1. This time we can see the index because it's noted, because so if you have a regular radical sign, it's just going to be a 2. Anyways, side note. So the interesting thing about these is you can kind of flip-flop between radicals and exponents. So this technically, you leave the base of 9, you bring your exponent, which becomes your numerator, and your index becomes the denominator of your exponent. So another way to write the square root of 9 is just 9 to the 1/2 power. Similarly, over here, we can write this as our base, which is 64. Numerator is the exponent that's in there. Denominator is our index. That's really 64 to the 1/3 power. So it's just a little trick. I kind of like it. This is kind of one of the things in math that it's just remembering how they work together and all that fun stuff. So go ahead and take a minute, see if you can reverse write these ones. I'll do the first one for you. So this is basically, remember, if you need to, 64 is our base in here. The top number becomes our power. This becomes our index. And then this is just the square root of 64, which is just 8. I'll do this one for you. 32. Numerator goes in there, index here. So we're looking for the 5th root of 32, which is 2. You can do that in your calculator, or you can think to yourself, what times what times what times what times what? We'll give you 32. Go ahead and try the other ones real quick, and then I shall show you how to do them. Okay, so this one is just kind of crazy. The way they have this written, this one is supposed to be a negative 4th root of 81, which I think the 4th root of 81 is 3. So this is a negative 3, where this one is the 4th root of a negative 81. But remember from the last video, if your index is even, you can't have a negative 1. So this one is technically no solution. This one, you can have the cube root of a negative 64. That's just negative 4. And in this one, you kind of separate them. So you take the cube root of 1 over the cube root of 27. The cube root of 1 is just equal to 1. The cube root of 27 is 3. Hopefully that makes sense. I know it went a little quick, but just to review from the last video, because I know that was one area that just I didn't super feel comfortable on, is the way the book writes it, if there's not parentheses around it, it does order of operations. So remember, order of operations is, please excuse my dear Aunt Sally. So you're going to go parentheses, which there are none, and C. Exponents, so the first thing it's going to do is it's actually going to do this thing right here. So it's going to take the 4th root of 81, which I believe is 3, because 3 times 3 is 9, times 3 is 27, times 3 is yes. And then it's going to negate it, so it's going to be negative 3. Where here, you have to think of some number. So let's try it. 3 times 3 is 3, times 3 is, 3 times 3 is 9, times 3 is 27, times 3 is 81. Let's try to get a negative, though. If I use negative 3 times negative 3, follow along, is a positive 9, times a negative 3 is a negative 27, times a negative 3 is a positive 81. I will never get, in real numbers, a negative 81, so that's why that's no solution. And then here, this is the cube root. So here, can I do this? So let's think about it. So this is saying that negative 4 times negative 4 times negative 4 is going to equal negative 64. Negative 4 times negative 4 is positive 16, times negative 4 is negative 64. So I can do that one. And then this one is just a separation. That's the thing I love about radicals, is you can always separate them, combine them. It's just another one of those like math puzzles that only maybe nerds get. Okay, so now this says evaluate each exponential expression, whatever. Here's how I do it. So if I were to write this, remember, this is going to be the square root of 25 cubed. Remember? Okay, so a couple ways you can do this, and I think it's easier to do this way, is I'm going to first take the square root of this guy. So the square root of 25 is 5, and then I'm going to cube that, so that's 125. You can also literally stick this into Desmos, and you'll get the answer. Same thing here. The first thing I'm going to do is I'm going to take the cube root of 27, and then I'm going to square it. The cube root of 27 is 3 squared is going to equal 9. To me, it's easier to go that route. Same thing with this one. The first thing I'm going to do is I'm going to take the square root of 16, and I'm going to cube it. So I get negative 4 cubed, 64, and then bring down that minus, so negative 64. This one, because it's in parentheses, the cube root is going to be negative 4. Squared is going to be positive 16. You can just stick these into Desmos. That's why I'm going a little quick. Can't do this one. What's the square root of negative 36? No solution. Even if you cube that, it still becomes a, you can go the other route for sure, but it just, by taking the root first, it makes numbers smaller, which I like working with smaller numbers because those are things I can actually do in my head, where this, yeah, that doesn't work. Anyways, side note. So even if I took negative 36 times negative 36 times negative 36, I would get a negative number. When I tried to take the square root of that, that's not working. Sorry, peeps. Not a thing. Write each exponential as a radical. Oh, okay, so take your time. See if you, I feel like this one should have been before the last one. Anyway, side note. See if you can do this one. I'll take a break. I noticed one thing on these things that I never take the same amount of break in between. Oh, and you guys are probably just like, we can pause the video, just keep talking. Anyway, side note, this one is just going to be the square root of 19. This one is going to be the fourth root of 11. Oh gosh, 11. We'll just pretend this one wasn't there. And then this one is a little crazy. So according to this one, because there's no parentheses, it should be 14 times the cube root of x squared. Now, if this was in parentheses, right, then it would be the cube root of 14x squared. Oh, then you'd have to distribute the square too. So this would be 196 times x squared. Now we're going backwards. Okay. Take a minute. Pause the video. Back from pause. Okay, so this is 37th to the 1/2 power. Remember, there's technically a 1 there, technically a 2 there. This is 9 to the 8 over 4 power, which is really 8 over 4. I think that's just 2, right? So this is 81. And then this is interesting. You get z to the 8 over 8. Well, it's 8 over 8. I think that's just 1, so I think that answer is just z. Okay, so this is the big boom. Everything to know about radicals, exponents, how they go together, all this fun stuff. If you were to take a screenshot, this would be my screenshot that I take. So geez. Okay, let's start up here. So if we have a base to an exponent times a base to an exponent, man, this is like last chapter. We're going to add those exponents together. So I love that they use 2/3 and 5/3. Like, can you not just use 2 and 5? Like, ugh. Anyways, look, they did it for the whole thing. Oh, I bet you, I know why they did it. Because it has to be rational exponents. Okay. All right. Pearson. Okay. Calm down. Yeah, anyways. Side note. So same thing with here. Whenever you're dividing, just like we did on normal exponents or whole numbers, you just subtract them. Power to a power, you're going to multiply them, power to a power. The reason why they did this is because they want you to see that this is really the cube root of 5 to the 7th power. So they wanted them to be fractional exponents. I'm sorry. So none of these rules are new. So distribute the r to both. Yeah, whatever. Yeah, magical fraction bar. Remember I talked about that? It goes down there. This one, double magical fraction bar, goes there. Yeah.